Dear students, two families of curves u x comma y is equal to c1 and v x comma y is equal to c2 are said to form an orthogonal system if they intersect at right angles at each of their points of intersection. Now, suppose that let's take this theorem. If fz is equal to u plus iv is an analytic function in a domain D, then we have to prove that the curves u is equal to constant and v is equal to constant form two orthogonal families. Now since fz is equal to u plus iv is analytic, it is given to us, so therefore an analytic function always satisfies Cauchy-Riemann equations, which we have proved in the last lecture. So therefore del u upon del x is equal to del v upon del y, and del u upon del y is equal to minus of del v upon del x. Now we have been given that u is a constant. So therefore suppose that u is equal to c1 and similarly v is equal to constant. Therefore suppose that v is equal to c2. Now because u and v are constants, therefore du is 0 and dv is also 0. Now u is a function of x and y. So therefore del u upon del x dx plus del u upon del y dy is equal to 0. Similarly, because dv is equal to 0, so therefore we have del v upon del x dx plus del v upon y dy is equal to 0. So therefore from this equation we have dy upon dx is equal to minus of ux upon uy, and from here dy upon dx is equal to minus of vx upon vy. Now if we multiply m1 m2 dy by dx denotes slope, so m1 into m2 is equal to minus ux upon uy into minus vx upon vy, which is equal to ux vx divided by minus vx into vy. Now we know that vx will get cancelled and ux is equal to vy by Cauchy-Riemann equation. So therefore m1 m2 is equal to minus 1. Therefore curves u is equal to constant and v is equal to constant form two orthogonal families. Let's take one more theorem. If fz is equal to u plus iv is an analytic function, then we have to show that u and v are harmonic functions. What do we mean by harmonic functions? The functions which satisfy Laplace equations are called harmonic functions. So we have to show that if fz is equal to u plus iv is an analytic function, then u and v are harmonic functions. Now since fz is equal to u plus iv is analytic, therefore ux is equal to vy and uy is equal to minus of vx, Cauchy-Riemann equations. Now we take second partial derivative of u with respect to x and second partial derivative of u with respect to y and add this. So del 2u upon del x2 plus del 2y upon del y2, which can be written as del over del x of del u upon del x plus del upon del y of del u upon del y. Now u upon this del u upon del x is same as del v upon del y, and del u upon del y can be written as minus of del v upon del x. So this term is del 2v upon del x del y, and this is minus del 2v upon del y del x. Now because v is a continuous function of x and y, so therefore these two terms are same, so they get cancelled and this is equal to 0. So therefore del square u is equal to 0. Similarly del square v is also 0. Therefore u and v satisfy Laplace equation and therefore u and v are harmonic functions. Okay, now next topic is construction of analytic functions. Now there are two methods. We will discuss one by one. Today we shall discuss the first method, Mills-Thomson method. Some people read it Myelin-Thomson method, some read it as Milne-Thomson method. But if you see some YouTube videos, there you will see the pronunciation of this is Mills, N is silent. So Mills-Thomson method. What is this method? Suppose that z is equal to x plus iy. Now if z is equal to x plus iy, then z conjugate, that is z bar, is x minus iy. So if you add those two terms, we get x is equal to z plus z bar upon 2. And similarly, subtracting those two equations, we shall get y is equal to z minus z bar upon 2i. So therefore, w is equal to f of z, which is equal to u of x comma y plus I times v of x comma y. In place of x, substitute z plus z bar upon 2. And similarly, in place of y, substitute z minus z bar upon 2i. Now by this method, what we do is we put x is equal to z and y is equal to 0. That means we take imaginary part to be 0. So if imaginary part is 0, then z is same as z bar. So therefore w is equal to, from this equation, we have w is equal to u of z comma 0, because this will be z plus z upon 2, which is z, and z minus z bar will be 0 because z is equal to z bar. So therefore w is u of z comma 0 plus I times v of z comma 0. Now f dash z, that is derivative of fz, is dw upon dz. Now because in this case we are taking z is equal to x, so therefore dw upon dz is same as del w upon del x, and w is u plus iv. So therefore this is del u upon del x plus I times del v upon del x. So which can be written as del u upon del x minus I times del u upon del y. We write this term in terms of partial derivative of u with respect to y. So taking del u upon del x is equal to phi 1 of xy. Now in place of x we write z, and in place of y we write 0. Similarly, del u upon del y is phi 2 of x comma y, which is equal to phi 2 of z comma 0. So therefore we get f dash z is equal to, of this equation, this is phi 1 of z comma 0, and this is minus I times phi 2 of z comma 0. So therefore f dash z is this, and therefore integrating we get fz is equal to integral of phi 1 of z comma 0 minus I times phi 2 of z comma 0 dz plus some constant c. Similarly, if v is given, then fz will be written as integral psi 1 of z comma 0 plus I times psi 2 of z comma 0 dz plus c dash, where psi 1 is equal to del v upon del y and psi 2 is equal to del v upon del x. Okay, let's take two examples. Find the analytic function fz, which is equal to u plus iv, of which the real part u is equal to e to the power x into x cos y minus y sin y. So we have been given u, and we have to find out the analytic function fz. So let's find out del u upon del x. Differentiate this partially with respect to x, treating y as constant. So let's use product formula. So e to the power x into x cos y minus sin y plus e to the power x into cos y, because partial derivative of this will be only cos y, derivative of x is 1. And similarly del u upon del y is e to the power x into minus x sin y minus sin y minus y cos y. So therefore at y is equal to 0, del u upon del x is e to the power x into x plus 1, because when we put y is equal to 0, cos 0 is 1 and this term is 0, and this term is cos y is again 1. So we have e to the power x into x plus 1, which we take as phi 1 of x comma 0. Similarly, del u upon del y at y is equal to 0 is e to the power x into 0, that is 0. So therefore by Mills method, fz is integral of phi1 z comma 0 minus I times phi2 z comma 0 dz plus c. Now phi1 of z comma 0 is, because phi1 of x comma 0 is e to the power x into x plus 1. So phi1 of z comma 0 will be e to the power z into z plus 1. And phi2 is 0. So we are left with integral of z e to the power 0 plus e to the power z dz plus c. So integrate it. So this will come out to be z e to the power z plus c. So therefore we had given u, and by using Mills-Thomson method we have obtained fz as z into e to the power z plus c. Let's take one more example. Find the regular function fz is equal to u plus iv, where u is equal to e to the power minus x into x squared minus y squared cos y plus 2xy sin y. So let's differentiate it partially with respect to x. So phi1 of x comma y is del u upon del x, and if you differentiate partially with respect to x, we shall get this expression. Similarly, if we differentiate partially with respect to y, we have phi2 of x comma y is equal to del u upon del y is equal to this expression. Now in place of x put z, and in place of y put 0. So therefore phi1 of z comma 0 will come out to be minus e to the power minus z, z square plus 2z. And phi2 of z comma 0 comes out to be 0, because y is 0, sin y is 0, sin y is 0, and again y is 0. So therefore phi2 of z comma 0 is 0. So therefore applying the formula, fz is equal to integral of phi1 minus I times phi2 dz. Now because this is 0, so therefore this is integral of phi1 dz, which is equal to, what is phi1 of z comma 0? This expression. So minus e to the power minus z, z square plus 2z dz. So integrate it and we get it as e to the power minus z, z square plus 4z plus 4 then plus c. And there is another method, like if you know u, then you can find out v, or if you know v, you can find out u. That we shall discuss in the next lecture. Thank you so much.